Good morning. So in this video, I'm going to show you a major problem with Sn1 reactions, or in general, any reaction in which we do form a carbocation in the first kind of step. So let's look at our substrate. So we're still going to use an alkyl halide, and we're going to react it with a weak nucleophile, also, or weak base. So what was observed in this reaction is that the major product was actually not what the expected substitution product was, but rather these other products. So in order to explain what actually happens in the reaction, the mechanism had to be elucidated. And so this is what was observed happening. So as usual, we're going to draw all the molecules involved in this reaction. And so I'm gonna draw all the carbons and CH3. So first step is still the same, meaning being a unimolecular type of mechanism, we have a carbocation formation. So we get a relatively stable secondary carbocation, bromide leaves. So what was observed in these cases is that the molecules can rearrange. So this is a secondary carbocation. And rearrangements can occur by migration of either a hydrogen or a methyl, with the hydrogen being preferred. So this is called the hydride shift. So the entire hydrogen with its electrons moves from the neighboring carbon. And so this gives a more stable carbocation. As you can see here, we're going to go from secondary to tertiary. So now the hydrogen moves. And so this is a tertiary carbocation. This is a condition that has to be satisfied in order for the shift to occur. In the final step, we follow the standard Sn1 mechanism, where our weak nucleophile attacks the carbocation. So this will give us the final product in two steps. New bond forms between the oxygen of the methanol and then we're going to do the final step, where another molecule of methanol is going to basically deprotonate. So we have to go around, remove this hydrogen, the electrons go back on the carbon. So this gives the final product, which is an ether. Plus, we also get protonated methanol as a byproduct. But as you can see, the product is different, and it's going to be the rearranged product, which also means every time you do an Sn1, as you will see in later videos, this also happens with competing elimination reactions. But the general rule will be every time you form a carbocation, and often secondary, there could be rearrangements. And the rearrangement leads to a more stable type of carbocation, has to be tertiary, and then the reaction proceeds. So the major product is often different from what we expect. Thank you, and I hope you enjoyed the video.